Hello, my name is Haoyu Wang, and here's homework 6 from class from class hw6 03 class. For the first questions, we are given x and y are joint density function fxy equal to 1 plus xy over a, which is absolute value of x and y all smaller than 1. 0 otherwise. So first of all, we need to find a so that above, so the equation above identified as a joint density function. So first of all, we do double integral for dx and dy. So the equation is 1 over a times 1 plus xy dx dy equal to 1. Then we will, after we do the double integral, we get 1 over 4 times a. It's like a times 1 over 4 equal to 1. And we see a equal to 4. And in second questions, we need to find out are x and y uncorrelated. Okay, we need to find out ex first. We do the same things to double integral. We get double integral dx and dy. So 1 over 4 x, 1 over 4 times x times 1 plus x and y equal to 0. And for ey, we do also the same. 1 over 4y times 1 plus xy dx dy, which is also equal to 0. And we do ex and y. So we have equation for that. So we can get 1 over 4 times x times y times 1 plus xy dx dy. We get 1 over 4 times 4 over 9, which is equal to 1 over 9. 1 over 9. Thus, we can get ex times ey, which is not equal to ex and y. So they are uncorrelated. For the third questions, are x and y independent? Here we go. For fxx times fyy equal to 1 over 4, because we know fx of x is 1 over 2, and the fy of y equal to 1 over 2. And then we get we need to find out fxy of x and y, which is 1 over 2 times 1 plus xy, which is not equal, which cannot equal to 1 over 4. So they are not independent. For the fourth questions, find the joint density function of x squared and y squared. So we suppose x squared equal to z and y squared equal to w. We can see here, and then we can get a matrix of the matrix of J, which are 2x 0 0 and 2y. Then we can draw in a figure that here is x-axis and here is y-axis. We put numbers in 1 2 3 4. So in the area of 1, x equal to square root of z, y equal to square root of w. In area of 2, we can get x equal to negative square root of z and y equal to square root of w. Area 3 is x equal to negative square root of z, y equal to negative square root of w. Area 4, x equal to square root of z and y equal to negative square root of w. Then for fcw of zw equal to fxy of xy over j, which is this x equal to negative square root of z and y equal to negative square root of w over 4 times square root of z times w plus fxy of negative square root of z and the square root of w over 4 times square root of z and w plus, which is 4 which is these 4 area that I mentioned here. So I put these 2 here. Then we can get the solution of these 2. We plug these 4 together. We get solution is 1 over 4 times square root of z times w, which we can get fx squared y squared of x squared y squared equal to 1 over 4xy. Absolute value of 4 times x times y. For the 5th questions, we need to provide and disprove that, prove or disprove that x squared and y squared are independent. Then we can see we have fzw of zw equal to 1 over 4 z to the negative 0.5, which is square root of z and also square root of it's 1 over 4 times 1 over square root of z times 1 over square root of w. Then fz of z is do the same things. Integral from 0 to 1 over 4 times z to the negative 0.5 times w to the negative 0.5 dw, which is equal to 1 over 2 times z to the negative 1 over 2. For fw of w, which is equal to integral from 0 to 1 over 4 times z to the negative 0.5 times w to the negative 0.5 dz, which is equal to 1 over 2 w to the 1 over 2, negative 1 over 2. Since we know fzw equal to fz times fw, we can get here x squared y squared equal to f squared times fy squared. So they are independent.